Welcome to our talk, Drum Up Support, Systematic Analysis of Image-Schematic Conceptual Metaphors, by me, Lennart Wachowiak, Dagmar Grohmann, and Xiao Xu. First, I will give you some definition of what image schemas are, and I will start by the canonical definition given in literature by Johnson and Lakoff in the late 80s, which is that image schemas are spatio-temporal cognitive building blocks that capture recurring sensorimotor experiences. To make a bit more clear what this actually means, I will show you some examples. First, we have the image schema source path goal, where an object moves along a path from a source towards a goal. We have the image schema containment, where one object is contained in some boundaries that differentiate between an inside and an outside. And then we have the image schema support, where one entity is physically supported by another. According to the theory, we learn those schemas during early infancy in an embodied and embedded fashion. After we learned them, we can reuse them to make sense out of new situations more quickly. Importantly, according to theory, we use these image schemas then later to make sense out of abstract ideas and topics, and this, importantly, is reflected in our language. So for instance, source path goal also structures how we talk about a competition with sentences such as, "The other company is ahead of us," or "We have fallen behind them." Support is not only used in the physical sense, but also in an emotional sense. For instance, here we say, "We offer support to a friend," or "We lean on a friend for support." So this is where we come to image schematic metaphors. So in the first case, we have the metaphor competition is a race, and the image schema is the underlying structure that is carried over from the race to the competition. And in the second case, it's even more clear where support is really directly carried over, and we have the metaphor helping a friend is physical support. So now in this work, we look at the research question of how we can detect image schematic metaphors in domain-specific language. And we look at how can we identify new and unknown metaphors, and how can we do so in a word class independent way. And to present our method, we do a case study of the image schema support in the context of a COVID-19 corpus. So why is this important? Why is extracting and understanding metaphors important? First of all, such a method can help improve corpus-oriented image schema and metaphor research. This can be cross-linguistic comparisons, literature analysis, or the analysis of the use of metaphoric language in political discourse. And in general, it can guide our understanding of metaphoric language, in which we want to answer questions such as how do we think and talk about abstract topics, or what does embodied cognition mean for language. Lastly, it has also been shown that metaphor extraction models can help with machine translation, where it sometimes can be really difficult to translate metaphoric sentences. In comparison to previous work, our approach does not rely on specific grammatical constructions, so other work often only looks at very specific combinations, for instance, verb-noun combinations as candidates for metaphoric language, and in our work we also make use of image schemas to facilitate metaphor extraction, whereas usually image schemas are ignored in the metaphor detection literature. Now a short overview of our method. First, we extract support-related sentences from the corpus. We then divide those sentences into metaphoric and literal sentences, as we are interested in the metaphoric usage of support in this corpus. Then we do a dependency parsing and analysis of grammatical patterns, which firstly tells us what grammatical constructions are most common, but also is used in the analysis of the next step, where we do a topic-based clustering and a frame analysis, which, as you will see, will be needed to identify new metaphor mappings, which we then do in the last step. But in the next minutes, I will show this in much more detail. So off to the first step, the sentence extraction. And here we create a seed word list by taking words related to support from sources such as WordNet, FrameNet, MetaNet, and relatedwords.org. We then manually cleaned this list before we used it to extract sentences from the coronavirus corpus. This then results in a whole bunch of sentences being extracted with up to 3,000 sentences for one seed word, such as help. In the second step, we then divide those sentences into literal and metaphoric sentences based on how the seed word is classified. Is it a literal or metaphoric usage of the seed word? And we do so by using XLM-Roberta, which we fine-tuned on the task of metaphor detection. So XLM-Roberta in this case gets inputs such as the sentence, "I lean on a friend for help," and then classifies each word as being either literal or metaphoric. And in this case, we would hope that lean on is correctly identified as metaphoric. So again, here we have the graph with the different seed words and how many sentences we have per seed word, but now we also add the statistics on whether or not those seed words were classified as metaphoric. And we can see that some of the seed words on the left, such as boost, maintain, and hold, are classified as metaphoric most of the times, whereas others, such as establish, livelihood, and subscribe, are nearly never classified as metaphoric. So we then go to a next step where we do a dependency parsing and an analysis of grammatical patterns. So here we look in what grammatical constructions do metaphorical seed words appear. So given a sentence or a phrase such as "give a lifeline," we feed it through a dependency parser. We are making use of stanza here, and it gives us a pattern such as a simple verb-object combination in this case. And then we count what patterns do occur frequently. Counting up those patterns then results in this table, where on the left we have the pattern, so here the verb-object combination, in the middle we have a language example, and on the right we have the count, which is increased by 1 for each seed word with which this pattern appears. So for instance, the verb-object pattern here appeared with 12 different seed words. The full table then looks like this, and we can make some interesting observations. So for example, for noun seed words, we see that the verb-object combination is very frequent, whereas patterns where the seed word is a subject are much less frequent, and adjective and adverb seed verbs overall are much less frequent than the others. Now to the step of the method in which we identify metaphor mappings, and a first way in which we do so is by doing a clustering. So given some sentences, as here on the left, all related to the seed word support, we feed them through our clustering method, which is called BERT-topic, which is a density-based hierarchical clustering. This then results in multiple clusters being generated, and we hope that they are grouped by the topic as here. So for instance, we have one cluster concerned with the topic of journalism, with sentences such as "please support local journalism," and we have another cluster more concerned with farming in the rural sector on the bottom. The output of the method looks like this, where we have the different clusters on the left represented by their most defining words, and these words are based on the TF-IDF values, and then on the right you can see the hierarchical structure of the clusters. So now this method allows us to do a more fine-grained analysis of two very common metaphors, which are assistance is support and help is support. And now we can see who are supporter and who are the supported entity in the COVID-19 domain. And here, for instance, we can see that journalism, food and farmers, and musicians are common topics, and those are the targets of support in the COVID-19 domain. Another type of support that often occurs is financial support, with clusters that are defined by words such as economy, financial, or billion. And then lastly, we also have medical support, with clusters defined by ventilator, ventilators, or hospital. The support that is meant here is life support. Then we have a second way in which we identify metaphor mappings, which is via frame annotations. And here we look at what frames the seed words and their related words evoke. So we have in the beginning the full sentence, which after dependency parsing is just the seed word and its directly related words. And those are then fed through BERT for FrameNet, which annotates the associated frames. And this again results in a frequency table, and we can analyze what are the most frequent frames. And again, we see something like assistance is support, very common metaphor, but we can also look at some interesting new cases. So for instance, we can look at taking sides, which occurred quite frequently, and we see that taking sides is talked about as support with sentences such as backing the campaign. Another example is compliance, where we have a sentence such as upholding the rule of law, so we also conclude there is a metaphor, compliance is support. Now some final discussion points. How generalizable is this method? We can use the method for any domain-specific corpus, and also we can use it for any type of image schema just by swapping out the initial seed word list used. Then some of the challenges we encountered. One is that it's a pipeline methodology, so the individual elements can propagate errors. So for example, if a seed word is wrongly classified as metaphoric in the beginning, the following analysis won't make much sense. And then the frame annotations in the end need to be analyzed manually to confirm if there's really a novel source target domain mapping found. In conclusion, we presented an approach based on state-of-the-art NLP methodology to identify novel image-schematic conceptual metaphors. This approach makes no assumptions about word classes and automates large parts of the work. Lastly, we use this method to identify support-related metaphors in the COVID-19 domain.